spend the next 45 minutes or so talking about building AWS compatible hybrid clouds. And roughly the agenda will follow this sequence. We're going to talk a little bit about both Cloudscaling and CumuLogic, and then we'll give you a landscape of what's really changing here in brave new world of IT. Obviously, proof is in the pudding, so both Sandeep and I will spend time showing to you how this hybrid cloud model works, and then we'll close it out with a Q&A session towards the end. So let's start with Cloudscaling. We offer a production-grade elastic cloud infrastructure system based on OpenStack. For those of you who are not familiar with OpenStack, it's a open source community that's growing by leaps and bounds. And it's an infrastructure that allows you to build the clouds, both private and public. Cloudscaling has taken that framework, and we're building a system that is modeled on the public clouds, such as Amazon Web Services and Google Compute Engine. Obviously, the difference is you deploy this as a private cloud within your data center and under your control. And today, we're joined with CumuLogic. So, Sandeep, you want to cover this slide?
Yeah, at CumuLogic, we initially started off as a Java platform as a service company, and over the course, we have expanded into providing a multi-language PaaS and Amazon-like cloud services, such as database, caching service, Elastic Load Balancer, messaging, and so on, and the latest addition as DevOps on the public, private, and hybrid clouds.
Obviously, we have a lot in common. We see the world, the brave new world, the same way. We see there's a transformation that's occurring here, and we will show you today how we are working together to deliver on that promise of the new world. So let's talk about this change of IT here. So we often talk about the public cloud. Amazon Web Services here is probably the biggest public cloud out there, growing at a clip of close to 100% year over year. And lots of companies that you're familiar with are building their applications there and actually growing on that cloud. And OpenStack, on the other end of the spectrum, is also a growing community. So we're going to talk about how we can leverage the best of both worlds here and really build these next generation applications. So let's take a step back here and sort of see what we're looking at here with the cloud. This is a typical technology cycle that we see every 10, 15, 20 years. Starting from the left to the right, we had the mainframes. You can sort of see the value that it provided. And then as we transition to the client-server model in enterprise, you saw that sort of break out. And really now with the cloud, we're really seeing this technology shift. And every single time you have this shift, there is going to be a rethink of what you do, and it impacts the entire stack, software, hardware, consumption. And really what we hope to leave you with today is really a primer on what this looks like from both, mainly from an application and SLA and consumption model. And why is this happening? Well, obviously it starts with demand, and we see these trends here change in IT. So let's start at the very top here. People are building different kind of applications than they did 15 years ago. The ones that you see here on the screen: SaaS, platform as a service, big data, our database as a service. These are all things that people are just used to. Application developers are leveraging significantly. Obviously, it delivers a better application at the end of the day. It delivers a much shorter time to market, and it's done in a way where it leverages a modern infrastructure. And so this really is driving it. You know, I think both Sandeep and I talked to a lot of people in this space that are building this, and I'm sure you on your mobile phone or on your tablet or even on your PC are using these new type of applications, generally accessed via a native application or via the browser. So that's one trend. Second trend is around shadow IT. This really speaks to the enterprise. Again, same a similar dynamic where you've got application developers that want to be able to develop and validate their application in a very agile manner. Unfortunately, they're not able to get that service from their internal corporate IT team, so they're going around that team and going directly to a public cloud Amazon Web Services is probably the best example of that. The final trend that we see is really this emergence of a hybrid first mentality in the IT space, where people really don't want to be locked in to anything. They want to be able to build an application that straddles both a private and public cloud. So the ability for you to have API compatibility and behavior fidelity is really key in terms of your IT strategy in this new world of the hybrid cloud. So again, these three things here we see very clearly occurring in the market, and both CumuLogic and Cloudscaling really have solutions that drive this, drive this home.
And also, for the applications, for the companies, they have to look at the two sides of it. There are companies with, on one spectrum we have the companies with all the, like you mentioned, the compliance requirements and the regulatory requirements to keep the data in-house. At the same time, there are other companies who have less stringent requirement and they can go onto the public cloud. But having said that, all of them still want to make use of the hybrid cloud solution, and they would end up making use of that because that's, that'll give them best of the both worlds and most bang for their buck.
Yeah, good points indeed. I completely agree with that. So let's dig a bit into these applications. So I think there's a lot of names to call them. So I'm going to use dynamic applications as a label for it, but I'm going to also talk about its profile and its attributes, because I think that really sums up the type of application well. So the names that you see up here are really the type of application we're talking about: database as a service, software as a service, big data, social, media. So these are stuff you don't see sort of the monolithic siloed application on this list. So we don't CumuLogic and Cloudscaling don't consider those applications that are monolithic and single stack to be a dynamic app. So I think really the bifurcation of the type of applications is important for us. But we also see a yin and yang between the application and the infrastructure. As we've seen on Amazon Web Services, where we see a lot of development and a lot of deployment of these applications on it, we also see that the infrastructure needs to be a good match for this application. So we call that an elastic infrastructure at the bottom. So you may ask, so tell me more about these dynamic applications. What's really unique about them? If I were to sum it up, really it comes down to two things. One is it's based on a scale-out model. As you can see here on the left side, is really an application that responds to load. So think of this as a marketing campaign that you're rolling out, and you're expecting only 1,000 people to take advantage of it. What happens when there are an order of magnitude or 2 orders of magnitude of people that show up? In the old siloed way of building your application would just fall apart. Right, you will not be able to serve those customers coming to your storefront. With these dynamic applications, all it's doing is we will spin up new instances on demand and really scale with load. And the reason why it can do that is because it can make modern API calls down to the elastic cloud infrastructure that underpins it. So that's one attribute of the dynamic application. A second one is the ability for it to manage and govern its availability, so its ability to self-heal. So this is an example where there's a failure in some component of the application. And there's a policy that says, look, if there is a failure in that part of the application, then spin up additional instances to make up the difference. And so again, in the old style legacy application, where a lot of this redundancy is built into the infrastructure, these modern dynamic applications are self-governing. So they do it themselves as well with the policy. So the infrastructure at the bottom can be built differently. So redundancy, ability for you to sort of build an n number of redundancy on the infrastructure level is less important. And that, of course, drives to much better cost and operational savings. And that's sort of, again, the yin and yang. You now have to really start thinking about a catalog approach to building your application. So instead of sizing your applications a different way, you tend to want to standardize it, because is just much easier on the infrastructure, much easier for the operations team to manage the application that you're driving. So again, taking a page out of Amazon's playbook here, you'll see that you can call a instance size, whether it's m1.small or a c1.extra large. You can call out the size of storage, whether it's object or block that you need. And then that then feeds into the underlying infrastructure that then drives towards what exactly you're building. And the nice thing about this, again, just like the application, that is a scale-out application, where as you need more capacity, you just load up another instance. The same thing applies for the elastic infrastructure. You can bring in a block of compute, build it out, and when you run out of capacity, you bring an identical block of compute and have it sit adjacent to it, and all of a sudden your capacity has doubled. So it's a very easy way for you to scale out, and again, this is how it's done by the public clouds like Amazon Web Services and Google Compute Engine. And so what that drives towards really is the reality that there will be two clouds that will thrive. On the left side is probably the cloud that you're familiar with. It probably exists in your business today. It runs legacy apps. It's probably virtualized. It's a siloed application that doesn't auto-scale, doesn't self-heal. But it does what it needs to go do. It serves the purpose in your company, but it does come with some legacy overhead based on the technology available when these stacks were built. What we're seeing now, and this has been driven home by Amazon Web Services, Google Compute Engine, and now OpenStack, is the emergence of these newer dynamic applications, which then require a new type of cloud, a new type of infrastructure that scales horizontally, that is distributed, very importantly, that is open, that drives significantly better price performance, that reduces the failure domain to a much smaller scale, and that's perfectly acceptable, and where it's completely API driven. So that's the world that Cloudscaling and CumuLogic live in, and we're seeing significant adoption of people that want to start building their applications in this new modern way. So you may ask yourself, so what do I have to think about as I look at things for the new Elastic Cloud? Well, this is sort of a high-level view of a consideration checklist. Obviously, it needs to be hybrid cloud ready. So whether you choose Amazon Web Services, Google Compute Engine, or another public cloud, you need to make sure that the solution needs to be tuned for that. You don't want to be in a position where your application can only be deployed on one cloud. You need to be able to push it out to multiple different clouds. Cloudscaling and CumuLogic, we obviously have embraced Amazon Web Services because of its market share and popularity in the market. But obviously, we're looking to be very open about other clouds, Compute Engine being one, that we can federate towards. Second thing is the same tooling and workflow, and that really, I think, is where both Sandeep and I will be showing you in our demos, where no matter where you're pointing your application, you're doing it the same way. And so that way you don't have to train yourselves differently, and you're just more agile and efficient in terms of developing and delivering your apps. Obviously, cost optimized, right? With the emergence of the public cloud, we've seen this as a service and charging based on an hour. So if you can change your spend to a spend that's more billing and usage based, that's something that you can really make a significant improvement. On-demand services, right? Again, if you're an application developer, you may not care the type of database that's there. You just want to be able to just pull it in, wrap into your application drive, right? So if you have to tinker with services, that probably isn't a good sign. That probably isn't a modern infrastructure and a new way of building apps. Equivalent services. So if you build your application on Amazon Web Services, for example, you want to ensure that as you bring components of it back into your private cloud, that you don't have to think about it, right? The underlying fundamentals are the same instance type, the same as a service, and you really don't have to refactor your application, right? What you do is you drive your application forward and just pick and choose based on security, compliance, costs, whether you put it on the public cloud or the private cloud. And same thing at the last item here, same thing about behavioral compatibility. You don't want to be surprised if your application is running at X% performance on the public cloud. You want to see that same performance or better when it runs on the public cloud. So these are things that both CumuLogic and Cloudscaling really drive towards, because we feel like this is what customers want in this new modern cloud era. So let's dig in a bit more here about, and picking on AWS, what do we mean by equivalent services? So and this is a high-level view, we'll actually break it up into a much richer set here in the next slide. Fundamentally, what you see on AWS, what people are using is they're using compute, which is EC2 in Amazon parlance, block storage, which is EBS, elastic networking, so whether that's VPC or the classic networking that AWS has, and object storage, or S3. So those are the fundamentals, and then there are also a bunch of web services that that you need that allows you to go build your applications very easily. And again, the ability for you to provide behavioral fidelity and compatibility and similar workflows to what's delivered on Amazon really is going to be important for you to ensure that you have a very smooth federation strategy. So let's break it down a little bit more here. And this is an eye chart, but I think it's really important for people to understand that without having the check marks, if you will, on these things over here, you're really not looking at a stack that can federate well to Amazon Web Services. And again, this is sort of where Cloudscaling and CumuLogic really see significant value in our joint solution together. So I'm going to pick a couple here from this, and I'm going to hand it over to Sandeep to also pick it out. So what Cloudscaling really focuses on, for example, is the first item on the list, AWS instance types. So this is the ability for you to choose an instance type on AWS and then have that equivalent on the Cloudscaling solution. That way, if you're asking for m1.smalls and you get X number of compute, Y number of storage, Z number of networking, then that same SLA applies to your private cloud. Same thing for storage. If you are able to manipulate storage in various different ways, whether you boot from it, whether you can take snapshots to it on AWS, you want to be able to do that also on your infrastructure, and that also speaks to networking and object storage. Sandeep, why don't you talk a little bit more about the web services?
Yeah, so just picking up some of the web services listed here, the Elastic Beanstalk. So the CumuLogic PaaS basically is, I would say, Beanstalk on steroids. It has all the functionality of the Beanstalk plus a lot more. Amazon RDS, so that is one of the service which is heavily used, and we have CumuLogic Database-as-a-Service, which is fully compatible with the Amazon RDS. Similarly, DynamoDB. So Amazon has DynamoDB, and what we have on the NoSQL side, we have created MongoDB-as-a-Service, and so on. So elastic caching, load balancing. So we have those services built on to run onto any of the private clouds and hybrid clouds.
And so I think this also, Sandeep, sort of sums up a bit more, but maybe you want to talk a bit more around the layer at the very bottom around sort of what you see in terms of the clouds out there, and also a bit more about some of the service platform.
Sure. So what you see here is a very high-level diagram of CumuLogic's cloud services architecture integrated with Cloudscaling's OCS Go hybrid cloud. As you can see, the core foundation is the framework service, which integrates the service components you see in the gray boxes, like the database service, elastic cache, messaging, load balancer, and so on, and integrates that with the underlying IaaS. So you would see here various clouds, including the Cloudscaling OCS Go. The framework is designed to provide various functions, like I said, the underlying IaaS integration. In addition to that, multi-tenancy, various ops-like features, monitoring, auto-scaling, self-healing, high availability. So some of these, as Asmir mentioned earlier, so very critical for the applications when they are in cloud. Either they are moving from one cloud to the other or running into various clouds. So providing the self-healing capability and high availability when the particular virtual machine goes down, if there's a hardware problem or something, and the platform is capable of automatically recognizing that and replacing that with a replacement of that node, and that is seamless to the application. Similarly, the other features provide the RESTful API, so that any of these operations onto the managing the application or managing any of these services can be fully integrated into your existing workflow or done using command line scripts and so on. Also includes other governance related features like role-based access, assigning quotas, and the metering, reporting, and others. So the way the core framework is designed, it is designed such that it makes the whole platform, the CumuLogic Cloud Services platform, extensible, so that in future, when we add more of those gray boxes you see, like when we add more of those services, they can be easily fitting into that framework and made available with much less time for the customer.
Awesome.
So when you will see the demo, you would see some of these the framework of actions we mentioned here about the monitoring, scaling, and others in more details.
Great, and I think I just want to share, because Sandeep and I have been talking and working together for a while now, but the first time we spoke, it was definitely a conversation around validation of the CumuLogic product on top of Cloudscaling, and I think it didn't take very long for you to validate your application, because by and large, the Cloudscaling infrastructure as a service product looked, smelled just like Amazon Web Services.
Absolutely.
Yep. All right. So so that's great. We've given you a sort of a picture of what's happening in the market space. We talked to a lot of people that are either doing it today or are planning to do it very shortly, and they're actively engaged with us. So what exactly does this look like, right? What are people experiencing? So we're going to spend the next 15 minutes or so going through a quick demo of sort of showing what people are seeing, and then we'll transition to summary and Q&A. So, hey Sandeep, can you see my screen still?
Yes.
Okay. So I'll spin up a couple. So my goal now is to spin up instances very quickly using a command line tool on both Amazon Web Services and Cloudscaling OCS. But I'm going to use the exact same command structure. And the whole idea here is that you don't have to learn, right? And then after that, I'm going to show you a quick GUI of both the Amazon Cloud and the OCS Cloud using the exact same tools. Again, all because we're all driving via the same APIs, it's very seamless for us to go do this. So, and to just keep things simple, I've actually created a bunch of scripts. You're going to have to trust me on this. All these scripts are effectively driving EC2 commands, and you'll see me go ahead and do that. So what I'm going to do at a high level, I'm going to go ahead and attach to the cloud, create credentials, create security groups, spin up instances. I'm going to rinse and repeat for the private cloud on that. So bear with me as I type through a couple commands here. So there I am connecting to Amazon. I get my key pair. I'm going to create a security group. And then I'm going to spin up instances. Awesome. Okay, so that's spinning up right now. I'm going to get now and do this exact same command, but on the OCS Cloud. I'm going to do it. I'm going to be lazy, and I'm just going to hit up the up arrow, and I'm just going to change some variables by using the exact commands, same command. So I'm going to go now to OCS, which is the cloud scaling solution. There you go. You see it there. I'm going to go ahead and create my key pair. I'm going to go ahead and create my security group. And I'm going to go ahead and spin up instances. And now I'm going to go ahead and change to a UI because it's much easier for us to see this at work here. So I'm going to go ahead and refresh here my view into AWS. So I had done a trial run here, but it seems like the instances still show up. But these are the ones I just at the bottom here are the ones that I just spun up. So there's 5 instances that I just spun up, and then this is the key pair that I created. I can go create security groups and elastic IPs and whatnot, and using the exact same tool. And you can see here we're connected to EC2 West. I'm going to use the exact same tool and look at my instances that I spun up on OCS. Let's go. Oh, I guess this ended up being. There you go. So these are the instances that I spun over here, and I can use the exact same commands to go run exact same commands on either side. So this short demo here is really to show that you can use the exact same tooling, making the same API calls, getting the same instance sizes, whether you're running on the Amazon Web Services cloud, or if you're running on the OCS-based private cloud. And that ability for you to federate between the two and share a variety of things really allows you to build applications that can straddle both clouds. So with that, I'm going to go ahead now and pass control to Sandeep. Did you get it, Sandeep?
Yes. Can you see my screen?
Yes, I can.
Okay. Thank you, Azmi. And that was a good good demo of how you can provision virtual machines across both the clouds and be able to see them with the same commands. So what you would see throughout the presentation here in the demo on CumuLogic side as well, that like I mentioned in the architecture diagram, that CumuLogic controller is also abstracting that layer underlying IaaS. So whether it is running on the Amazon or running on the OCS cloud or running on dedicated, created dedicated resource pool on virtual machines, and you would be able to see seamlessly deploy applications on one or the other without having to worry about the migrating applications. Now, the demo here, what you see, this is the CumuLogic controller set up on the OCS Go cloud. So we will just walk through some of the cloud services here, which we talked about in the earlier slides. So one of the most important AWS service, like we said earlier, is the RDS, Relational Database Service. So let's see how CumuLogic Database Service will provide the comparable cloud service for hybrid clouds. Now, our goal is to keep parity with the AWS services, like you saw in Azmi's demo as well. So if you're familiar with Amazon RDS, then the CumuLogic Database Service wouldn't look any different in terms of features or functions available to you. So let's go and provision some service. So similar to RDS, to launch a database instance, this is a CumuLogic dashboard. From here, you will go on to either go through the database service here or the services tab. So we'll just look at both of them. Click on the details, and here you'll be able to see details of the service, and here you have some of the plans. So these are pre-created plans, so admin can, as the owner of the environment, can set up some of the plans which are pre-bundled services. You could pick one of them depending on your requirement and just launch it. So here you can see that I have a small database, for example, with 1 core, 1 GB RAM, 10 GB storage. If this is what I'm looking for, I could just click here and launch instance. That will create a fully functional database service on the underlying cloud. So, and then if I wanted to create a cluster, so I could look at that and say, here I have 3-node cluster definition with this much of storage. I could just go and launch that. And here is a large database. So depending on your requirement, you would choose that, and you would be able to just go click on launch, give it some name. So I'm just going to launch one database service. So here I'm just going to call it demo 3. And then here I could just directly launch it, or if I wanted to customize some settings. So this was a prepackaged bundle, so I could just go see what I can customize. I can tag this environment. So this is my development testing. So I'm going to mark it as a testing database. I can just go with the defaults. So, or I can, here I have option to set my backup preferences. So in CumuLogic, we have a default backup happening once a day that can be set by admin. but as a user, if you want to change that and change your retention time or start time, so you could click on the preferences and set that. So by default, the retention is for 1 day. If you wanted to provision a database with a retention time of 5 days, for example, you could just choose that. And here in the start time, you will pick up a start time. So by default, the backup starts at midnight. You, let's say, want to start at 2 a.m. So you could just set that up. And now we are ready to launch this database instance. So we can launch. Now what is happening is it is provisioning a database instance in that there is dedicated resource pool I have, and it will take one virtual machine from there, configure MySQL, and make that service available. So while this database service is getting provisioned, there is, like I mentioned, the other way you could also provision. If you don't want to use one of the pre-packaged bundles available, you could pretty much go into launch instance from here and walk through all these screens, fill up all the information, choose what size you want, how much storage you want, provides different username, password, different port number to run, and so on. Once you select all that, you could just launch that service instance, and a database service will be created. So while this database is getting created, this will show here in progress, and here in the events tab, you could monitor the progress of what is happening. Through the provisioning process, it is transparent to you. You can see that instance is getting created, instance got created, then configuration is happening, and so on. So as this is getting provisioned, let's look at some of the other actions which are available. So similar to what you see on Amazon now, if you wanted to take a snapshot of the database, so here you can go click on create snapshot, select one of the database which is available, and then say give it a name. So like I mentioned, there's a default backup snapshot which is happening through in the default window. But if you wanted to take an ad hoc snapshot right now, let's say that I'm doing some update to my application, I wanted to take a dump of my database right now, so I could just go and call it I just want to save it right now, so I will go and create a snapshot on my database. So a snapshot is being created right now, and then that database will become available immediately once the snapshot is taken. Similarly, to scale out applications, so as you can see here, we have provisioned these applications with a single node. So now if you wanted to add more capacity, you wanted to scale this database further, we would be able to go and click on actions, and here there is various actions which are available. So let's say that I wanted to add a read replica for this database. So this is a single node right now. I wanted to scale out. I can go here and click. It's just going to create databases, take a snapshot of database, and add, configure that as a master slave, and create a database. Now you will see that a new database instance will get created here in replicas. Once the instance is up and running, the replication is configured, then you would have access details of both the servers, and you would be able to configure your application to read all your read-only actions like reporting and others can be run off of the replica database, and the write operations can go from the master. So once we have the other actions now, like once we have taken the snapshots, then if you wanted to restore from snapshot, so once I have the snapshots available, and if I wanted to create another instance of my database based on that snapshot which we just created, we could just go and say restore from snapshot. So there is an option for you to now, similar to what we have in Amazon RDS. So here you have option to just take that snapshot and choose the size of give it a name, select the service type of the instance size, and restore that, create a new database with that snapshot which we just created. Also, the other option which is available is point-in-time restore. So it's great that we can restore it from a snapshot, but if we want to restore it, so there's a snapshot happening every, let's say the window is still 24 hours, but if we wanted to restore something in between that, then you could just do a point-in-time restore. So CumuLogic keeps backup of the bin log files and the snapshots. So using those two, combination of that two, you can restore a database to say, let's say as latest as 5 minutes ago, or you could set up, say, if you know that some change happened at certain time and you wanted a database restored to something previous to that, you could set up that time window here and then restore the database to a particular time window. Parameter groups. So similar to Amazon, there is for performance tuning of your application. So you can fine tune your application. Let's say you have your database running for some time, and based on your workload requirement, now you realize that you wanted to have some fine tuning done to the application, to the database. So by default, when the database was provisioned, if you had a parameter group created previously, you could apply that, and the database will get provisioned with that. If there was no parameter group specified, then the database get created with the default values, and you have a choice to go and edit that parameter group later. Or so here, you can create a parameter group by just making a copy of the existing the default parameter family, and then make changes to that. So I have created this, let's say, demo, and I'm going to go say view edit parameters. Here is a list of all the parameters which are available. So after running your application for some time, you realize that you wanted to increase the query cache size. So it is, let's say, currently set to 0. I wanted to set it to on. So I just save it to 1. And let's say I wanted thread cache size to be 100. Or I wanted to have max connections, for example, which are set to 100. I wanted to set it to 300. So once I change whatever parameters I need to, so here on this table, you'll be able to see what kind of parameter it is. It is a global or local parameter, whether it is dynamic or not. So some of them, if you see here, some of these parameters are dynamic. That means they can be changed or updated without having to restart the database. Or some of the parameters which are non-dynamic, if you modify any of these values, when you wanted to apply this, it would mean that a database will need to get restarted. So once you see all these, these are possible values, default values, all this information is available to you. You can set whatever tuning you wanted to fine tune your database and save that. So once you have saved it, now you can go back to the instance which we have created previously and go into modify action. So during the provisioning, we selected few preferences for the instance. So we had selected backup options. So if that time we had selected no preference, and now we wanted to change that, so you would be able to select like what we did during the provisioning time. So you can select a different retention window, different startup time, and so on. And here you can apply a new parameter group. So let's say that we modified the demo parameter group here. I wanted to apply that. Now I have two choices. Like I said, if I apply that right now, if I have any of the non-dynamic parameters, that means the database will get restarted. Or if I don't want, because this is my production database and I don't want it to be impacted right now, I don't want to bring it down, so I can just say modify. What would happen is during the next maintenance window, the parameter group will get applied, and the database will not get restarted, but it will get restarted during the next maintenance window. So let's just say that I'm going to apply it right now. So it will just get, the parameters will get applied. So once the parameters are applied and database is available, the status will turn to green here again. So now let's take a look at the other action, which is similar to RDS, which is access group. So this is similar to the security group in Amazon, where you have you can control who gets access to your database. So this is our demo environment. We have just opened access to all the ports here, all the IP addresses, but you can pretty much edit this access group. Similar to the parameter group, you could have some access group created by default and grant access to your specific IP addresses or IP range, and then save that. So during provisioning, you would have a chance to just select that access group. Or if you just let the instance get provisioned with the default access group, then you can pretty much go here and modify the access group by giving a particular port number, change it to a particular IP address range, and so on, and then apply. So that changes will get applied to the database. So this is how you'll be able to control the security on the databases. So this was all about on the database service. So we have a standalone database. We were able to add the read-only replica to that, take backup, restore it. CumuLogic also supports MySQL cluster. So here we have a standalone MySQL and then MySQL cluster. So during the provisioning, you can choose a cluster and then choose number of nodes you want to provision with, and provision the cluster similar to what we have done for the standalone instance. And then all of these features apply to the cluster service as well. Now we extend the same functions as we saw for the SQL service to rest of the services in CumuLogic. Now you have NoSQL database service. So here, this is mapping to the Amazon's DynamoDB. here we have MongoDB added here in the service, and we are adding other NoSQL databases to this list quickly. Rest of the things here would follow similar, like you would be able to launch instance from here or from the service plans created previously. You would be able to take the snapshot of the database. You'll have parameter groups similarly available to you, so you'll be able to view, edit, and apply certain parameter for your non-SQL databases and set those values and fine-tune your database. Access group is a similar control available to that. Now on the other services, like we mentioned, so we have a SQL database as a service, NoSQL database as a service, load balancer. Load balancer is we are using supporting Nginx load balancer. It's a software load balancer. And in the frameworks we have, like I mentioned before, that we support Java, Tomcat, PHP. Within Java we have Tomcat, JBoss, and so on. In PHP, plain JVM as a service for your old POJO applications. Spring, Grails, and Python. Support for some of the other languages is coming soon. So you'll be able to provision pretty much the standalone service. If you wanted to create just the Tomcat instance, provision that and directly deploy applications or configure and modify that. Similar parameter group, access group controls will apply. And then last but not the least, we have the Elastic Cache. So this is Memcached-as-a-Service, where you'd be able to provision a Memcache instance, use that in your front-ending to your database or in your application, and use that as a service. So what we saw here is, provisioning individual cloud services, modular cloud services on the underlying OCS Go cloud, and with few clicks. Now let's switch gears and let's take a look at how we can deploy an application. So I'm going here to the application, and we can see how we're going to deploy an application to the CumuLogic platform. So like I mentioned, that we started off with the Java platform as a service and expanded into other languages. So here we would see, let's just take a look at how to deploy a simple Hello World type application in here. So this is the application dashboard. You'll see I can deploy an application, click on deploy, give it a name. So I'm just going to select, let's say test web is my application. Then I'm going to provide application WAR file. So this is a simple J2E application. I have a WAR file here, and then a small service descriptor. So this is a small XML file with the description of what I need for my application, like defining the services, the components of the application, and so on. So I'm just going to show you that descriptor shortly. Here I'm going to click on customize so that I could deploy directly the application. I'm going to customize to just walk you through some of the flows here. So if I have more than one target cloud, like I mentioned, I have the OCS Go cloud, and also I've created a dedicated virtual resource pool, so I could deploy to any one of them. The one of them is set as default, so if I don't give anything, I just say deploy, it will just get deployed to the default pool. Now here I'm going to go and select this for the interest of time, and say click on next. Now here on this screen, if my application needed any database information, that would have been already read from the XML file we provided. But since this is a non-database application, you can just click on next from here, and then see that I can. So if I did not provide the XML file with the details what I need, I could pretty much go through this whole screen, or just click on deploy on the first screen itself to deploy the application directly. So here I can customize and select if I have to change any of these configurations, or I have a Tomcat framework selected and I Nginx. So I'm going to say deploy. It's going to reconfirm. Now here is the summary of what I selected to deploy. So here is the target cloud information where this is getting deployed. Here is my application information, and here I have what services I chose for this application. So I selected a Java Tomcat container with 1 node and 3 nodes to be able to auto scale up, and this is the size of the instance and so on. And I have one Nginx load balancer. So I'm going to click on finish. So this will go and start deploying that application. So it will pick up the 2 nodes from that pool and then start deploying that application. Now while this application is getting deployed, so let's take a look at, so we can see the status here will show in progress, and in the events tab at the bottom here you will be able to see what is being done at this point, and you'll be able to follow the progress from there. Once the application is deployed, you will see application URL become available here. So here in the other 3 tabs, you can see the framework. So as you saw, we selected Tomcat framework. and as it starts getting provisioned, you will see the in progress details here. Now here we will be able to follow the progress of the application. Now see, this application is getting deployed. Once the application is deployed, there are the other tabs which will become available, like the logs, the monitoring access group is similar to what we saw on the other side, and the logs would be able to see the log of the application and whether look at the log online here or download the log file and take that. So let's see if this application is getting deployed right now. So we would see the progress. So the load balancer got created and the framework is getting created right now. As you can see, the application is getting deployed. So once the application is deployed, we would be able to configure, there are some actions which will become available here, like the undeploy the application, configure domain, and since we selected this application to have more than one node possible, then we would have actions also available for being able to scale up configuration. So auto scaling configuration, you'd be able to configure based on CPU, memory threshold, and so on. So in summary, we saw here being able to deploy various CumuLogic the services, cloud services, as well as deploying application with a few clicks on the underlying cloud. So while this application is getting deployed, I'm going to hand it back to Asmir for the next.
Yeah, that's really, so Sandeep, that's really powerful. And you know, just to drill in here, because you were going through quite a bit there. You were effectively playing a developer, and you were able to spin up instances, get volumes, create security groups, really by yourself, right? You didn't have to go, obviously you didn't talk to anybody, and you were able to really drive and deploy an app there in minutes, right?
Absolutely. Absolutely.
Yeah,
and as you can see here, so we are trying to hide all of that complexity of having to worry about the underlying infrastructure configuration and tying all of those pieces together in the platform side of it, where you would see that as a developer, you don't have to worry about how my Tomcat is going to talk to my MySQL database or the load balancer is going to get configured. It is all done for you by the CumuLogic controller behind the scene, and then it is making use of the underlying OCS Go Cloud for all those features for getting the security group, the access group, the IP address mapping, and so on.
Yeah, and I think you're just making API calls to us, and really internally here at Cloudscaling, we feel like we're really delivering value to customers and also to partners like CumuLogic when they don't realize we're there, right? They can make an API call and it behaves the same way. They don't have to think about exceptions for a private cloud. They just build it the same way, and then what you see is the value of time to deployment, ease of deployment, the ability for you to sort of just be competitive and create things on the fly and really empower that developer community. So again, I think hopefully you see here what it is, and the underpinning of it is still the same. It's compute resources, it's block storage, it's networking, it's security groups. We take snapshots. You can use object storage. So all of those things are the things that we provide as the infrastructure, and that gets wrapped up by either tools that solutions like CumuLogic provide, or you drive it via an API directly from the customer end. That's great. Let me let's transition back to slides here. And Sandeep, can you see?
Yes.
See the slide? Right. So I think hopefully we'll just to sum up here. Obviously, this is the brave new world. It's modernizing. This is a new technology stack that's coming to being. It's the cloud, the cloud era, and really that data center modernization requires elastic infrastructure, right? Amazon showed the way, Google's showing the way, and we've learned a lot of lessons here, and we're building the cloud scaling solution based around those lessons too. So there are a bunch of things that we can do just using x86 servers and open source software. So that's really something that really to consider here as part of how you adopt and embrace the new stack. The second thing is around the quote unquote full stack compatibility. It's not just about APIs. It's not just about a sprinkling of software. It really is the entire stack. This is a modern way of building applications and thus building the infrastructure. And you really need that checklist of things. You need to have the right vendors playing together that have that vision around how applications are developed and how you run your data center. And so that really is important. And then finally, what you see on the screen here, really, companies are already embracing this new paradigm. This is not a 2015 initiative. This is now. Both CumuLogic and Cloudscaling are actively talking to customers today that want to deploy a hybrid-first mentality, that want to look at ways to leverage both the private and public cloud to really drive this new paradigm. And so homework for the people that are online today. So obviously we'd love to hear from you. These are email addresses that you can reach out to us. You can also go to our website. We've got a ton of resources available, and I think it'll be good for you to complement sort of the webinar today. I'll leave this up for a little bit. And then I think, Robert, I'm going to transition back to you here and see whether we've got any questions from the audience.
We do have actually quite a few questions, and we'll see how much time we have to get these covered during the time we have remaining. The first question is, can hybrid cloud be used with PaaS, or is it more suited to infrastructure as a service?
I'll take that first, and then Sandeep, maybe you can chime in here. So I think the hybrid cloud really is flexible, right? The underpinnings are around the API and behavioral fidelity, and as long as the applications and the platforms above it are driving the infrastructure using APIs and expecting some level of fidelity relative to the public cloud, then a hybrid cloud strategy will work for a bunch of these applications. Relative to PaaS, maybe Sandeep, I think you're probably well positioned to answer that one.
Yeah, I would just add to that. Yes, it would work for both. I would think as the IaaS, you would be able to expand, like you just demonstrated, go from one cloud to the other seamlessly, and being able to use it from the single panel, or from using the same consistent commands across. On the PaaS side, of course, you should be able to deploy the applications without having to worry about which underlying IaaS you are talking to. That would be the hybrid model, and absolutely it will work with PaaS as well.
Great, thank you. Second question, and Sandeep will direct this one at you, and then Asmir, you can chime in. It's pretty specific, so bear with me. You mentioned that the cloud infrastructure would not support a monolithic application. Can you clarify this? For example, if you have an application running CICS on IBM MBS OS platform with an Oracle SQL database and telecom connections running SNA, could the application be ported to a cloud infrastructure or portions thereof? Sandeep, why don't you start that one?
Yeah, absolutely. So depending on how the application is created, so that I can see here mentioned that you have application running on CICS at this point, and then you have Oracle or SQL DB in the back. So absolutely, from a platform, you will be able to deploy the application part of it into the platform and keep the database outside of the cloud if you choose to. So that way you'll be able to deploy those applications. It doesn't have to be all or none. So you could always break the application. So like I mentioned in my earlier comment, as for the hybrid cloud, for the customers who don't want to keep their proprietary data or have the compliance regulations keeping the data outside in the cloud, they would be willing to keep that in their database, in their premises, and make use of the hybrid cloud for running the application part of it, and talking back to the database in the backend.
Yeah. I have a slightly different view of things, and this is more taking a step back and looking at technology trends and transitions. Every time there's a transition, people tend to take it with a cap and grow mentality, where they have existing investments with a prior infrastructure, and they cap the spending on there. And then they start off greenfield with the new technology, and then really put a lot of effort and applications there. So in the case of what you called out, Robert, I think most companies that I've spoken to tend to say, look, it's probably working well in that previous infrastructure, and it's probably going to require a lot of effort to try to retool and make it work with this new infrastructure. So we'll just cap it leave it on there. You know, mainframes are still around, right? So that's a good example there. While client server, and also cloud are growing, right, for enterprises. I think that you know, for me, I think there's definitely a segment of companies where they'll just leave that application sitting where it is, probably just runs as good as it does. But any new application, they really want to think about you know, this elastic infrastructure and a, you know, sort of a very developer-centric view of the world where they can drive things without having to interact with IT.
Great, thanks. We'll try one more here. What does Amazon or Google think about the trend toward the hybrid model? Are they working more closely with OpenStack vendors to create a world that's hybrid and open, or are they pushing back on that?
Yeah, I'll take that. So we'll start with AWS. So the AWS API is in OpenStack. It has been from day one. The roots of OpenStack came from a contribution from NASA, and NASA drove their compute cloud using the EC2 API. So it's been there, and you know, as long as, you know, OpenStack just celebrated its 3rd birthday, you know, we don't see any issues from AWS. And then relative to Google, Google's a new entrant in the market, but I think there's a lot of exciting news that we'll probably be able to share here in the next month or so on that. So I guess,
yeah, I kind of agree with your view on that, Asmir. I mean, there's no reason for them to push back. I won't think they would be pushing back, because it's, you know, the more people are creating Amazon compatible, using the compatible APIs and creating those hybrid clouds, it is, you know, it is kind of working hand in hand together to because those the hybrid cloud, the other part of the hybrid cloud is going to be Amazon cloud anyway, so you know it will work in their favor in that sense.
And we'll have time for one last question. We'll pick one that springboards off that last one. It says, if you have compliance data that will never leave and can't go beyond the firewall, can you still scale out the compute resources in the cloud for peak periods?
Absolutely. So that's a perfect use case. You keep your sensitive data in the private cloud. You spin up the stateless part of the application in the public cloud.
Sandeep, anything else on that?
That's it. I agree.
Wonderful. Well, we've reached the end of our hour. Thank you so much to Asmir and Sandeep. Just a reminder, we will send out an email to all of the participants for the replay tomorrow, which you're free to share with colleagues or anyone else you think might be interested. That concludes our webinar. Thank you so much for attending.